everyone. In this video, we will be learning about binary search, one of the most powerful and efficient searching technique in data structure. In this, I will walk you through the logic, how it works, where we use it, and also show you a simple Java code to implement it. So without wasting the time, let's get started. What is binary search? We already know that searching is a common task in programming, right? Now, imagine you are searching for a number in your phone book. You don't check every contact. You go straight to the middle, decide whether to go up or down. That's exactly what binary search does. So, here, binary search is used to search for an element in a sorted array by repeatedly dividing the search interval in half. But remember, this only works when the array is already sorted. We use divide and conquer search algorithm. Now, before going to how know about how binary search will work, um, let's quickly talk about some rules. For binary search to work, the array must be sorted and we need random access to elements, so it works best on arrays, not linked list. If the array is not sorted, binary search won't work. So that's the basic requirement. Now, let's see how it works. We start with a entire sorted array. Um, and also we have two variables, like one is low and one is mid. The low is the starting or the beginning of the array, and high is end of the one. We find the middle element using the formula mid is equals to low plus high by 2. I will discuss it later. What we do here is we compare the middle element with the target. We have a target that need to be searched. If the target is less than the middle element, we search in the left half. If the target is greater, we go to the right half. We repeat this process until we either find the element or the range becomes invalid. This is why it's super fast. It keeps cutting the search area in half. Don't worry if you did not understand anything. We will see more examples so that you can understand very efficiently. Next. This is the step by step process how binary search will works. Firstly, we required a input sorted input array, and next we will define the ranges. That means low means starting, high means ending of the index, and middle one is by using the formula we get the middle index. We compare the middle element with the target variable. Target variable is what we have there for searching. Next, we adjust search ranges based on the comparison, and we will repeat this until target is found. Our program will return no program is found. Okay, next. Okay, this is the example. We have a input array, sorted input array, and our target is to find the 9. We should find 9. We should return the index of the 9 where it is presented. Okay. Next, see, this is the initial array. Um, initial array. This was the initial array, and we are searching for the 9, and its names as your target. It's step 1. These are the indexes, and we have low and high. Low and high. Low is at the starting index, and the high is at the ending index. Now let's calculate the mid. Low plus high by 2. It's the formula of the mid. What is the low index is 0, and what is the high index, it is 9. So 0 plus 9 by 2, it's 4. And what is there in the index of 4? The element 5. Let us check if 5 is less than or less than 9 or greater than 9. See, our target is 9. 9 is greater then the 5. Greater than means we have to search the right half, means this right half. We should search in this right half, and we need not to search in this left half. So we should uh, see how efficient is this. We cancel the entire left half. We need to check in this half only. Okay, coming to next step 2. uh, Here it is the low and it is the mid, and we have calculated the mid. 5 plus 9 by 2 is 7, and what is there in 7? It is 8. um 9 is greater than 8, so we will again search only right, and we will eliminate the left index totally. Next step 3, again we calculate the mid end. We got the mid as index 8, and in that value is 9. So here target and our search element uh, is same. So the element is found. Sorry. Yes. And our element is found here. At what index we will found our target value at the index 8. So element found at index 8. See, in just the 3 steps we found the number. That's the power of the binary search compared to checking every element one by one like linear search and all. Let's implement a Java code. I mean, let's explain you a Java implementation very simply. First, we will initialize variables, and next compute midpoint, and compare and adjust element found. Let me now show you how we can implement this in Java. I will use a very simple example so it's easy to understand. You can follow along on an online compiler too. Okay, let's write a code. And now let's actually write the code for binary search in Java. Don't worry if it's look complicated at first. Just think of it like a detecting narrowing down a list of suspects. Let's define a method. See, first thing first. Sorry, I have titled it here. Okay, first thing first. Let's create a class. This is the class we have created. I will call it as binary search example because, well, we are doing binary search and this is an example. Creative, right? Next. Now we write a method called binary search. It takes two inputs, an integer array ARR, which is already sorted, and a target value. This is the guy we are trying to find. Kind of like we should find the. Now, next step is setting low and high. See, we have a array, right? We have this array, right? Um, First, we should calculate. We should sorry. See, Starting we should initialize something, right? So let us take low is 0, means starting index of the array, and high is we don't know what is the size of the array. So let us think it as n minus 1. For that only we need to write the code. Let's initialize it. Int low is equals to 0, int high equals to array dot length is a method for finding the length of the array. So we start with the two pointers, low and high. Um, Low at the beginning of the array and high at the end of the array. Imagine we are in a library and we are searching for a book on a shelf. Low is the first book and high is the last one. I think now you have understand. Now let's write a loop here. We will use the while loop. While less than or equals to while low less than or equals to high. This loop says keep going as long as there is still something to search. If low crosses high, it means we have searched the whole shelf and still did not find the book. Time to cry or return minus 1. For the detailed explanation, um, here is the array. Let's take a simple array 2, 3, 4, and 5. Let's take this small array 0. These are the indexes 1, 2, 3, and 4. So, what we will do means we will check. Firstly, low is here, right? And high is here. We will check everything like coming forward and back. Uh, if the L goes here, here the index is 5, but there is no element here. So L is 5 and H is 4. H is 4. Here 5 is greater than 4. That means our loop should be stop here. That is what here we are writing the while code. This is what the exact meaning of while code. And next, let us find the mid value. Int mid equals to low. Calculate the middle index in binary search. We usually write this. Now it's look fine, right? But wait, there is a small danger here. Let's imagine what if low is a very large number and high is also a very large number. Um, for explaining this, mm, let's take another Java compiler. Suppose low is very large number like this, and high also very large number like this. Some random values. So if we try to do mid, int mid is equals to low plus high I 2 system dot out dot println of mid. Let's run the code and see what happening here. See, it was showing integer number is too long. Okay, okay, wait. It is not. I want to explain. For your understanding, let us print low plus mid also. Let us take our low value as some random numbers 3, and let's make low plus high. What it will printing? See, here the answer is we got is minus 21474 something. But what we want here 2147483648. But we got the answer in minus. This is why means the int has last number is this one, and if we try to add something means it will come to the first. So um, Java's int type can only store values up to uh, 214748364 something. That's very big number. So if we do low plus high, it goes beyond the limit and causes something called integer overflow. It wraps around and gives us a negative or random wrong value. Our mid will be totally messed up and binary search will behave weirdly. What's the safest way for this? So for that uh, case, we write low plus high minus low by 2. Here why this is better means high minus low is just small value. Um, let's go into the example then. Let us go with the example. If we write sorry, low plus high by 2, we're getting some negative integer like this, right? So let's use this one, low plus high minus low. So now we got the right answer. This is what's the main function of this one. We then add that to the low, which avoids crossing the maximum integer limit. So we never add the two huge numbers together and avoid the integer overflow. It's a small change, but in real world applications, this can prevent bugs and errors. So yeah, our midpoint is now both smart and safe. And next, we will compare if array of mid equal to target. We should return mid. If the middle element is exactly what we are looking for, we return that index and our mission is accomplished. For the better understanding of this, see, we have the array 1, 2, 3, 4, 5. Uh, 1, 2, 3, 4, 5, 3, 4, and 5. The low is 0, the high is 4, and 4 by 2 is 2. So the middle element is 3, and our target is also 3. That means our target variable is found at index 2. This is the code here. Next, what if array of mid is not target? Else, if the mid value is less than array of mid is less than target, means what we have to do? See, our now wait. Now our target is not 3. Our target is 4. Sorry. No, our target is 2. Our mid value is 3. If mid value is less than target, we should see that. If yes, it's less than target, means we search the right half of the array. So we update low. Here we update the low. Low is equal to mid plus 1. Else, and we have another case, right? If else is array of mid is greater than target, we should increment the high, mid plus 1. Okay. Now here's where the binary search gets smart. If the middle value is less than target, we search in the right half of the array. So we update the low here. If the middle value is greater than, we go to the left half and update the high. Basically, the algorithm says, nope, not here. Let's search where it's actually makes some sense. Unlike me when I am looking for my keys in the fridge. And next, if nothing is found, means let's return some -1. This means if the loop ends and we still did not find our target, then we return -1. This is like the computer saying, bro, I checked everything, it's just not here. Like that. Now, let us code the main method. Let's test our method. I have created a sorted array from 1 to 10. Let's create a sorted array. Int array is equals to 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, 9, and 10. Okay. And next, our target is 9. And let's say we want to search for 9 because 9 is cool, like almost 10, but not too mainstream. Um, Let us run the code. Oh, sorry. I did not call the method. Let's call the method. Here I wrote and let's run. So our output is 8 and we get our target at the index 8. Okay, let's back into the our PPT. Okay, here is the Java code. You can see here too. And let's discuss about the time and space complexity. All right. How efficient this algorithm is. Time complexity is big O of log n because every time we divide the array into half, right? So the time complexity is big O of log n. The space complexity is big O of 1. We don't use any extra space. This is the way better than linear search, which takes big O of n time. So binary search is clearly a winner for sorted arrays. And next, let's see some applications, some real world places where binary search is used. Searching for your name in your phone contacts. It is one of your best application. Autocomplete suggestions in search bars. And finding elements in sorted list, databases, high scores list in games, and more. It's everywhere behind the scenes where fast searching is needed. So that's it. We have successfully understand binary search, a super efficient algorithm that cuts down our search spaces like a boss. We saw how it works step by step, how to implement it in Java, why we use low plus high minus low by 2 instead of low plus high by 2 to avoid integer overflow and all. Remember, binary search only works on sorted arrays, so always sort first if needed. This algorithm is like a shortcut in a maze. It does not check every path, just the ones that make sense. And that's what makes it so powerful in coding interviews and real world problems. Thanks, and I hope you learned something new. If you are still curious, try implementing binary